Welcome back. So in the last session we went through how to set up your cam for the ST20. In this session we're going to look at some specific simple OD operations. So to perform an OD operation you need to have your setup active. Now if you look at this, we can see that we have excess stock on top and we want to remove this excess stock till we come to the top surface of the part. So to do that, most likely your first operation is going to be turning face. If you click on turning face, you'll have to select a tool, and this should take you to your cloud libraries, under which you will go to the specific machine that you're using. In our case, we're using ST20. So I'm in ST20, and now I have a lot of tools to select from. So at this point, it will be handy to learn the filters. Now for facing, we will always use a turning general. Now there are two shapes of turning general available. One is a C-style 80-degree diamond, and the other one is a V-style 80-degree diamond. So if you look at the V-style, let me readjust that 1 second. Remove. Okay, back to ST20. If I click on it, this is what a V-style insert looks like, and let's look at a C-style, and this is what a C-style insert looks like. Now which style you go for really depends, and it's something that the TA is going to help you with. Now I'm going to show you in this case. In this case, I can see that I have to face the top and I have to take the sides. And I know that a C-style can do this job. So I'm going to select a C-style. Your specific geometry will dictate which style of insert is optimal. So I'm going to go for a C-style. And even in the C-style, I have a couple of options. Now the way you figure out which option to go with is by knowing what material you're working with. So we are going to assume that in this example we're working with 6061 aluminum. That is going to have an ISO classification of N2. So the first tool in the selection has an N2 cutting data, so I could potentially use that. The second one does not. The third one does. The fourth one does not. The fifth one does not. And the sixth one does not. So my two choices are the two KC5410s. And I can select either one of them and it would be valid. So I'm just going to go with the Ken lock variant. There is a Ken screw variant, but I'm just going to go with the Ken lock variant. I make sure that my cutting data is selected and I hit select. Once I do that, it is advantageous to see what the cam is doing. Let's click OK. And if you look here, it's going to come down, dive down here, make a cut, come out and go back. So let's see this in simulation. Dive down, make a cut and go back out. Now this might seem okay, but this is incorrect. So let's look at the simulation and let's try to find out what are the things that are incorrect. So right here, if you look, we are making contact up here as well. And while you're facing, you really don't want to exceed this point on the insert. So there's an easy way to do this. And we're going to edit our operation and go to the passes tab. We're going to enable multiple passes, which means it's going to do it in multiple steps, and we're going to set an explicit step over, and that explicit step over will be tool underscore corner radius times 0.9. Now this is an equation that you can use for any style of tool you're using for facing. whichever tool you select, it's going to take the corner radius, multiply it by 0.9 and use that as a step over value. So let's click OK and see what that means. So hit simulate and we're going to be here. Okay, so what it's saying is take this corner radius and only use less than 90% of it. So it will never be able to get onto this edge, because the rule that we have specified for step over is take the corner radius and use only 90% the depth. And this will ensure that we can face correctly. Now there is another behavior here that I don't like. You're on the machine, everything looks lined up, and suddenly your tool takes a small dip into the material. This is not going to be helpful if you're looking at the tool and looking at your stock and anticipating that it goes straight forward, because it'll go down and cut. And that could mean that you could miss a potential crash if you didn't account for it diving down. One easy fix for this is to change that behavior. So I go to linking, and here I'm setting an angle called linear lead in angle. And I'm going to set that to 90 and click OK. And let's see what that did. Simulation, my tool is here and it goes straight into the material. So at this point there is no weird behavior. Now as a result of the change we made, we introduced another unwanted behavior. It's made the cut, but it is now dragging the insert back on the material, and this will excessively wear down the tool. So to change that, we go back into linking and we unselect same as lead in. So lead in was your entry. Now we're going to define a lead out, and we're going to keep that at 45 degrees. So if we come here and hit simulate, it's going to make a straight cut, pull up and out. It's going to make another straight cut, pull up and out, another straight cut, pull up and out, and it's done. At this point, we have successfully defined the operation. Now I see some other behavior that I'm not happy with. You see the transition from the green to the blue. The green is your lead in and the blue is your cutting action. Now this is fine, assuming the stock that I have is exactly what I set it in CAD. Now we require that you actually exactly model your stock, but more often than not people make mistakes, and a more cautious approach is useful. So what's controlling the start of this blue line is under radii, and the term is called outer radius. You can see outer, and it is set to exactly the size of the stock. What I can do is give myself some breathing room. So I can set an offset of 0.1 that moves this slightly outside, so it starts cutting action slightly outside the stock. This ensures that even if the stock was slightly bigger, we should not run into problems. So I'm going to hit OK. And we can do the same thing up here as well, or at least attempt to. Here it assumes that the stock definitely starts here, but if I made any issues with placement of the stock in the chuck, it could start cutting earlier than anticipated. So I go to multiple. Actually, never mind. You cannot control this. So you have to place the stock exactly where it is stated. And if anything, it has to be further in the chuck than further out. Because if it's further in, it will not make the cut. But if it's further out, the tool is going to take a much bigger cut than you programmed in. And with that, we have done our first operation. I'm just going to quickly go over what are the basic things that make operations. In the first tab is tool. You select your tool. That should auto set your coolant type. You make sure your preset corresponds to the material you're cutting. That should auto set the rest of the values. Geometry helps control the region in the Z-axis where you'll make the cut. And Radii controls the region in the x-axis where you will be transitioning between lead in, lead out, fast motion and cutting motion. Passes controls how the different cuts are broken down, and linking controls your lead in and lead out behavior. And for the next few operations, I'm going to be running through this a lot quicker. Let's click OK here. And our facing is done. Now it's advantageous to try to use the same tool in your subsequent operations. That minimizes the number of different tools you need in order to achieve your cam and will result in less time spent in front of the machine. The next operation, I'm going to cut out this profile. So I'm going to start here in turning profile roughing. I'm going to use the same tool. Now since I'm using the same tool, I'm going to click on the existing tool in my document. So whenever you select a tool from the cloud, it creates a copy in the document, and you should not keep reselecting from the cloud if you're using the same tool, because then what you will have is multiple instances of the same exact tool. Like I already have here, there are 2 entries and only one of them is being used. So I'm going to fix this by removing unused tools, and I'll reselect the tool I used in the previous facing operation. And now I'm going to go to the geometry tab. So it is OK. I'm just going to click OK at this point and see what happens. So I click OK, and I have a couple of problems I want to solve. So the first problem is I want to make sure the steps that it is taking, they are an appropriate amount of step. So for roughing, you need to make sure that the maximum cutting depth is equal to something called tool underscore, I think it's step down, and click OK. Let me check the step down value. Okay, in this case I'm just going to quickly check the tool properties. Edit, cutting data. No, it's called tool underscore depth of cut, so that's the wrong equation that I used there. So we go to passes, we type in tool underscore depth of cut. Now for the most part, if you selected your preset correctly, it should automatically apply that equation. Okay, so that's good. Now there's one behavior I don't like here. That is the fact that it starts right from here. So I might want it to start a little further out, just in case my stock is slightly bigger. So that I can control with the radii. And with that, I can set it to be 0.1 bigger right there, and it's starting the blue passes slightly outside the stock. The next thing I might want to control is I know that later I'm going to cut it off right here, and when I do perform that cut, my tool is going to encounter some material here but no material here. And this is unhelpful because you're going to load your tool unevenly. So to ensure my tool is loaded evenly, I might force this to go down further. And the way to force it to go down further is to come here and apply a tangential extension. So I'm going to target a 1/4 inch tangential extension, which basically takes this point and tangentially extends it further down. And when I make the cutoff, I encounter clean flat surface. The next problem that I have is this is a roughing operation, and it's leaving a very small amount of material for my finishing operation to take care of. This small amount of material needs to be about the size of the step over. If it is not, it will not load my finishing tool correctly. So I'm going to come in here, hit edit, and I can see that the step over is roughly this value. Now I'm going to leave step over in X, but I'm not going to leave any stock in Y. So I'll set this to 0 and I'll make this 2 underscore depth of cut. Now I am lucky here that for my finishing I'll be using the same tool, and since I'm using the same tool I can use the depth of cut for this tool. But if my finishing was a different tool, I would have to leave X stock the same size as the step over of the second tool, not the tool I'm currently using in roughing, but the tool I'm using in finishing, because I want to leave enough material for the finishing tool to take one depth of cut pass to finish. So I'm going to hit OK, and now you will see that there's a decent depth of material in X, nothing in Z, and more in X. The next thing I'm going to do is create a finishing operation. I'm going to come here, I'm going to stick to the exact same tool, and I'm going to, just like the last one, extend this to go 0.25 further down tangentially, and I should not have to set anything else. Now if I look at it, it is starting from here, but I want it to start a little further out, so I'm going to start modifying this operation. So to control the Z, I can make it go tangentially forward as well, 0.1, and now it is starting from here, going straight down, then coming back up. I am seeing a warning, lead out has been modified due to a gouge. So let's see what's wrong with the lead out. The lead out is set to the same as lead in, so which means it's trying to do a 45-degree lead in here, which is fine, but when it tries to do a 45-degree lead out there, it will run into the stock. So I'm going to define my lead out explicitly and set this to 90 and see what happens. Now at this point it is coming, cleaning, and pulling out. It's not trying to do a 45-degree. This means that I no longer have the error because everything seems to be in place. Now let's look at a quick simulation of what we have achieved so far. So we have our facing operation, and we face, and I see no collisions. We have our turning operation, and we will get close to the chuck, but we're not hitting it. And after our roughing is over, we come in for our finishing. And now all we really need to do is chop this part off. For that we will use turn part, and we'll go to select, go to ST20, and for parting we will always use a turning grooving type. Now there are a couple of options here. There's one of this, one of this. Now this is for ID, and we're not cutting off the inside, we're cutting out the outside, so we're gonna take this out of consideration. This one is ID. These other ones are for really tiny cuts, like 31 thou, 62 thou. So these will also go out of consideration. That leaves us with two options. One is a round insert and the other is a cutoff insert. Now as you can see, this one is specifically designated for cutting off, and if you scroll down, there's some instructions provided in the comment. Can do grooving and part off. When parting, reduce feed by 75% when insert width away from center. Now that's a mouthful, and I will show you what that means. The first thing we're going to do is we're going to select N2 because that's the material. We're going to select the one that is specifically designated as cutoff. That will be number 7, beyond evolution, grooving and cutoff. and hit select. It automatically selects our geometry as the back of the model, so we won't worry about that, but we will come to our passes and make a few modifications. The modification we are going to make is used, reduce, feed, and speed. Once we do that, if you remember what was said in the tool comment, is reduce feed by 75% when one insert width away from the center of the part. So here it's asking me the radius at which it starts reducing feed. I know that I have to do this when I'm one insert width away. So I can use an equation again, tool underscore groove width, which is the same as the insert width, which means that when you're one insert width away from the center, it will slow down. How much will it slow down by? 75%. So I'm going to redefine this as tool underscore cutting tool underscore not cutting width, tool underscore feed cutting. So the cutting feed times 0.25. So if we take the set cutting feed and times it by 0.25, we are effectively causing a 75% reduction in feed. And I'm gonna hit OK. Reduced feed rate exceeds cutting feed rate. That does not sound right. Reduced feed rate, tool underscore feed cutting real times 0.25. Okay, that should be correct at this point, and let's see what that value ended up at. That looks like 0.0009, so approximately 0.001 or 1 thou. And here we can see that it is approximately 4 thou, and 1 thou seems pretty close to 25% of 4 thou. So that's okay, and we have a part of. Simulate. And our part pops off and we've made our first part. Now, a lot of people will make this part and then work hard on cleaning up the edges manually. That is unnecessary. This is CAM. There is no reason that you shouldn't use the CAM to make your life easier. So we're going to go back to design and make a few modifications to part simple. So I'm going to isolate, and maybe I don't want this sharp edge, so I can chamfer that sharp edge. I don't want this sharp edge, and this sharp edge, and I can go for a value of 5 thou. And these are small breaks. Maybe I can even go for a value of 10 thou and click OK. And when I do that, I can switch back to my manufacturing, and I see these circles indicating that I need to refresh my tool path. So I hit generate, and let's see. So my facing is working correctly. My profile is also working correctly. My profile finish doesn't seem to be working correctly. So let me see simulation. So I will pay close attention to profile finish, and my part off seems to be working correctly, but my part off angle seems incorrect. So let me see what's happening here. Simulate. Facing seems fine. Okay, this seems just like before. Oh, interesting. So if you see, it tried to take a cut downwards like this. The tool should not be doing that. You see how it's making contact here? it should not be doing that. So the reason it is making contact here is because of the settings we provided. So if you remember, we provided a tangential extension from this point. Now the tangential extension from this point will be this way. So I can't select that as my bottom. So I'm going to explicitly define a bottom. I'm going to select this as my bottom and a tangential extension from there. So that would mean the tangential extension goes straight down. As you can see, now it goes straight down. Now my profile still has the same tangential extension selected. So I'll make a similar modification. I cannot select this as my bottom because the tangential extension is this way. So I am going to explicitly define it to be right here. And now my tangential extension will be straight down. If I click OK, there we go. Now you will notice a problem. Simulate, and I'm going to skip through facing, roughing, finishing, and let's look at part of. So the problem that you guys should notice is that we have not made this chamfer, and the best way to make this chamfer is to use the part of tool. So I right click edit, I go to geometry, and I enable the option called edge break, and I define my chamfer to be 0.01, which is what I had set, and I simulate this explicitly, and you'll notice a problem with this as well. Simulate. So it tries to make a chamfer somewhere over here, but the actual chamfer is here. And the reason this is happening is because of the outer radii that we have selected. If you see the outer, it has been selected as the outside of the stock, but in reality it is the outside of the model, which brings our chamfer in line with our actual model. So now if we simulate facing, roughing, finishing, our chamfer and part of, and we are done. At this point, you would have this cam ready to go in front of a peer mentor to fix minor errors and get approval. That's it for this video. In the next video, we're going to explore more complex OD operations.